That's the chain. So let me give you another example. Y equals sine of cosine of the square root of x. Do we have any multiplication here? Is there anything times something, like a function times a function? No. The square root of x is sitting inside of what function? Cosine. That's sitting inside of sine, which is sitting inside of another sine. So let me try and write this out. My y is equal to what? Sine of something, right? U? So I'm saying this is my sine right here. This is my sine. My u is all this crap. There's my u, right? My y is sine of something. Now what's u? U is sine of cosine of square root of x, but I can look at cosine of square root of x as something else, right? So let's call it v. And my v's look like r's, sorry. So now I'm talking about, it's kind of weird here, the sine here is actually this sine right there, isn't it? And my v, I'm going to start running out of colors, is actually everything in there, right? Okay, what's my v though? My v is cosine of square root of x, but square root of x is a different function. So I'm not going to say cosine of square root of x, I'm going to say cosine of w. But then what's w? Square root of x. Do y'all see? We did this in the past, but do y'all see how that broke down? Now, what you want is for every single one of your equations to be something you know how to take the derivative of. So that's why I did not write, like in this step right here, I did not write cosine of square root of x, because I don't know the derivative of that, because it's not a product. It's a chain rule. So that's why I didn't do that. That's why I put w. So now I'm going to set my table up. The first one I have, I'm going to be doing what? dy du. And that should be? What's derivative of sine of u? Cosine of u. Okay, next one should be d what, d what? U d v, right? Which is again cosine of what? V. The next one is d v d w, which is negative sine of w, and then dw dx, which is 1/2 or 1/2 root x. So now to get to the answer. The answer that I want, right, y prime, is equal to dy dx. But using the chain rule, this is the same as dy du times du dv times dv dw times dw dx. And then that means you just multiply those all together again, right? So all I'm really doing at the end of the day is I'm taking this right side of the column, this right column here, and I'm multiplying all those answers together. Cosine u times cosine v times negative sine w times 1/2 root x. So I'm going to write that down over here. Y prime equals cosine, what was it? U times cosine v times, in parentheses, negative sine w times 1 over 2 root x. Questions? Questions? Oh, no. Yeah, that would be nice. Everything has to get back in terms of x. So let's start plugging things in, and I'll kind of go slow through this. What is u? This is sine of v, right? Then I have times, what's cosine of v? So what's v? Cosine of w. And then times negative sine of w, but what's w? Square root of x. And then 1 over 2 root x. So all I did in that first line was I replaced my u with sine of v, I replaced my v with cosine w, and I replaced my w with what? Root x? Do y'all see that? And now I got to go again. What's v right there? We have sine v right there in the green. What's v? Cosine w. So just be careful with your parentheses here. It's cosine of sine of what? What's v? Cosine w. Close that off twice. Times cosine of what's w? Square root of x. Close that off, close it off. Times negative sine of root x. I don't need to do anything there. Then times 1 over 2 root x. Now I got to keep going, right? So in this line, all I did was I replaced v with this. I replaced w with this. How many more times do I have to do this? Just one more. I just got to get rid of this w, right? So I have cosine of sine of cosine of root x, close, 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 times cosine of root x, close, close, times negative sine of root x, close, close, times 1 over 2 root x. And that's it. We're there. It's disgusting? Is that what you said? Yeah. Now look, honestly, a Calculus 1 student, by the end of this summer, if you're asked to take the derivative of this up here, the original problem, should be able to do it mentally without making a table. And I'll explain how, because what I've shown you so far, everything I've shown you has just given you a mechanical way to do this. But there is another way that I think is much easier, but in all my years of teaching, people either see it or don't. So I don't want to give you just one method. This way is one, and now here comes the next way. So I'm going to show you now the previous problem we did with a different way. And you get to kind of, I guess, ease your way into it. The first problem we did was sine, was it x squared plus x? No, the one before this one. Sine x squared plus x. Next to this, I'd like to write the answer of what we got. It was cosine x squared plus x times 2x plus 1, right? That's what we got? Yes? Okay, now, that's where we're headed. Let's see if I can get to that red answer by doing this a different way. Look at your y equals on the left side. If you were the x value, right? If you are x, this is like an onion. What's the last thing that happens to you? The last thing. If I just plug in a value, it would be x squared plus x, whatever that is, right? So if I plug in 2, it'd be 2 squared plus 2, which would be 6, right? Then what? Sine of that, right? And that would be it, right? So would you agree that sine is the last thing happening? Yes? Sine is the last thing happening. That's where you start, okay? That's where you start. So watch how I write this. Y prime equals I don't know how to do this other than to get up on the board, but sine's the last thing, right? So I would like for you to just squint your eyes, if you can, and tell me what is the derivative of, forget the purple, everything purple. What's the derivative of sine of x? Cosine x, right? What's the derivative of sine of v? Cosine v. What's the derivative of sine of purple? Cosine of purple, right? I mean, that's what it is. So what I'm going to do is first, starting with the last thing, which is sine, I ask myself, what's the derivative of sine of purple? It's cosine of purple. But what's purple? X squared plus x. I'll fill that in a second. Now, I go inside to the next layer of the onion. So I'm done with sine. I multiply now by the next function inside of sine. So imagine now that sine's gone. What was inside of that? The purple, right? What's the derivative of the purple? So I'm going to put the purple here, but I want its derivative, don't I? So I'll put a little like derivative mark next to it. So if you can fill this in, cosine, what was the purple? X squared plus x times, what's the derivative of the purple? 2x plus 1. And that's this. Right? Let's do another one. The one we just did, the cosine of sine of, we'll do that one in a minute. Let me kind of baby step you into that. How about, as an example, y is equal to tangent cubed x squared plus 1. I want to find y prime. Now you could do this the way I showed you a little while ago, making a table and doing your d whatever, multiplying them all together, plugging back in. But let's see if we can't get this by doing a shorter way. Y prime equals. So if you are x, what's the last thing happening to you here? The cubed, right? Cubed. So imagine now that we have purple cubed. What's the derivative of purple cubed? What's the derivative of x cubed? 3x squared, right? So 3 purple squared? That's the derivative of purple cubed is 3 purple squared? Yes? Okay. So 3 purple squared. So I need that squared. So let me put parentheses squared. Times. Now what's the next thing inside after cubed going back in? What would be the thing that would have happened next? Well, the derivative of purple, but look at the purple. Isn't the purple something inside of something else? So what's the last thing? Just look at purple. What's the last thing happening in purple? Tangent, right?